Hi guys, today we're going to be talking about probes, multimeter probes and so on. And I hope you guys will bear with me. My equipment leaves a bit to be desired for recording videos. I need to get some better upgrades over time, but also I'm not very good at presenting, and English being my second language, actually sometimes I get a bit tongue-tied, so um, maybe with practice I'll get better at it. So I hope you'll bear with me. Um, so when you buy a multimeter, you will find that you will get these kind of probes with it, with stubby tips on them, and they're good for general purpose work. But if you got like little circuit boards like this is a tiny little 6-pin chip over here. If you want to touch one of the legs on it, some are even finer than that. Of course, these probes are not very useful. You might end up actually shorting out a couple of the legs if you accidentally touch two of them at the same time. So I've been buying some over the last 5 or 6 months. I've been buying different probes to try them out, and I thought I would present the results that I've found so far. I've got 3 sets here. The third set I probably got from AliExpress or maybe Banggood. I can't remember. But the other 2 I bought from Amazon. This is one set that I bought. These came in a little box, and they're actually interesting because the actual body of the probe separates from the lead, and then you can actually plug in different kinds of, these are actually the leads here, different kinds of leads, even a little crocodile clips or something, and on the other end or what have you. So they're very flexible, and also the tips on them you can plug into a crocodile plug socket, and so we'll have a look at those. See, there's the tips on them, and how they pull apart, and so that's about it. So that's one set. The second set I got is these, and of course these have smaller needle-like tips on them, which are important for working on, as I said, working on those small components. Came with a bunch of extra bits and pieces, some of which, like these guys here, I don't use. Every time you plug something into those tips, you actually add resistance and it becomes a bit unwieldy, so that's not something but I would recommend. But it did come with a pair of these tweezers, and which is useful, and these guys I like too. It came with little plug-in grippers for very fine wires or very fine little legs on ICs and so on. You can grip with those, and they tend to you can plug DuPont pins into them. There's the lead is one, but there's an open socket there you can plug something into as well. So it becomes kind of interesting sometimes when to hook things up. As I said, these things here I don't tend to use, these big crocodile clips. Maybe one day I'll have a use for them, I don't know. These I don't use because the actual probes have already got, crocodile clip thing on them, and I got leads I've made up myself, with crocodile clips on ends, and but better type clips. But these needles, of course, is one of the reasons we got this. That's a standard tip. That's what we're trying to avoid having to use. So that's the 2 kinds, and I've got a third one as well, as I said, but I don't have I can't remember where I got those, but we'll look at them too as well. So I've got 3 sets that I use for different purposes. They have strengths and weaknesses. So the first ones we can look at are actually these. Let me turn that little camera back on. Take that little board away for a second here. these are the ones that have the you can take the little cover off, and you can plug them. You can then plug them into a banana socket. But these are also the ones, you know, that came with with these kind of things. You can plug those in. But as I said, I haven't used those, and these crocodile clips came with them that will plug into them. And as they showed, you can actually separate the body from the actual probe. And which means that you can plug other things into them. Now these have pretty good low resistance, but they're about 34 milliohms, I think. However, they don't come. These didn't come with needle points, but I bought these things here separately that I use, and they came with a whole bunch of needles, and those, of course, I can plug into that lead here, and then I can use those. And as I said before, these are fine enough, you know, to be able to get to some of those pins. Oh, I can't see it. Fine enough to get to little pins on these ICs. So that's a good thing. And you know, these little components here. So that's one way. And these things are relatively cheap. They came with lots of spare needles. So if you ever damage them, you can replace them. Rated at 10 amps according to what's printed on them. And my desk multimeter actually has a 20 amp capability, so I would have to find, if I was ever going to measure more than 10 amps, I'd have to find something better to use, and indeed one of those here has got 20 amp ratings. The second ones that I have that I showed you are these, and they have needle tips in them, on them. You can actually remove the cover, and then you got a long needle, or you can put the little cover on, and then the needle is shorter in case you want to avoid shorting out. These unscrew, and it came with a spare set of needles, but just one set. And it did come with a bunch of these fat standard tips that, as I said, they're only used for general purpose work, not for, so I won't be using those with these probably. And then we have these things, but in order to use those, you do have to put sort of a standard tip in them. These little grippers that I said, they clip onto there, and then you have that thing there, and they've got little very fine little grippers. They can grip onto that, but they can grip onto very fine wires as well, which is a useful thing. They hold on pretty good there. And sometimes if you're working on very small components, like cell phone PCBs, you could sometimes solder a little fine wire onto something and clip these things on to watch signals. And of course these got DuPont pins that plug into there, so you can actually add another lead to it like that. And so now I have a thing with a banana plug on the end plugged in as well. Anyway, who knows, one day that might be important. So that's that. These ones have also pretty good low resistance, but they don't have, most of them don't have silicone leads, and already it's kind of touched it with a soldering iron or something, and you see a tiny little blob on there that was melted. Which brings us to the next ones where I purchased them, but they are similar. These are actually 20 amp ones, so I can use those with my benchtop multimeter if I ever had to measure a high current situation. Now these also come with these stubby tips, of course, but they came with these guys that you can plug in, and then you've got some long sharp needle like things, but you got to watch these, they can bend. But they're insulated, and they work okay. Now this one here actually has silicone rubber wire, 20 AWG. I wish I had used thicker wire like I will be using to make our probes here. I purchased some wire which is actually 16 gauge silicone wire. I got 5 meters worth, and this is good stuff. Nice fine wire in it that is flexible. And turn that off. This nice fine wire here makes it very flexible, and silicone wire. So however, these are good as well, but they actually have a slightly higher resistance than the other ones, even though they say they're 20 amps for some reason, but not much, only just, you know, like maybe 10 milliohms or something like that. So that's what we have. And I'm going to stop the video now. I'm going to get set up to talk about Kelvin clips and to make them up. Okay, a little insert over here. I forgot to mention these tweezers here. They can also be handy. They can be used, you know, on small circuit boards like this to measure S&D components in circuit, like a little resistor or a capacitor like that, and even this inductor over here, and little LEDs and so on. So I do use those occasionally. Okay, so let's talk about Kelvin clips and banana plugs. We're going to be using these solid metal banana plugs on account that and they get soldered, no screws, on account that these cheap banana plugs that you can find on Amazon, on AliExpress and so on, they are very poor. For a start, the screws, if you try to tighten them up nice and tight, the screws come undone. The loose threads, and this one over here, see, I can just push the screw in. It's totally lost its threads. And secondly, these twirly little metal things on there. They're loose on there. They're hardly making a contact. And even so, if you look at the milliohm meter over here, so if I connect that, if I connect it to the plug here, and I just take it to the body here, just about below where that twirly thing is, you can see it's a good contact. 0.2 milliohms, 200 microohms. Actually even goes to 0.1. But now if I see, this is like a bare banana plug socket. If I plug it in and I connect this to the socket, look what happens. It never makes a great contact, and it just keeps changing, you know, according to the that loose twirly thing on there. It's just, you'll never get a reliable reading if you were trying to use something like that for low resistance or low capacitance or something like that. So these things are no good for our purpose. So put that to the side. So we're going to be using these solid ones here, and you'll see, like if I plug this in over here and do the same thing, you will find that there is no problem whatsoever. You know, and whenever you make a contact that is not soldered or something, there's always a tiny bit of resistance. It's got 0.5, a half a milliohm. So that's what we'll be using. And why are we using these? As you can see, this milliohm meter also has this these so-called Kelvin clips on it, and it actually has two leads coming out of it, one here and one there, and they are connected to the different the two little beaks of the it's just what you're going to call them on the tips there. One wire and another wire, so that one. And the reason for that is that, as you can see on the milliohm meter here, it has 4 leads, and what they do is they inject a voltage on one lead and then measure it on the other lead. And to make a long story short, the end result of it is that therefore you get an accurate measurement just at the tip, and the resistance of the leads can be calculated out that way. So that's why we can set it to 0 and get an accurate reading without taking the resistance of the leads on account. Okay, so but also these Kelvin clips, I got them from AliExpress for $3.48 for 2, and they actually can grip onto things like it grips on just fine on this. See, quite a good tight grip on this thing here. It can also grip very fine wires like that. It's a nice, you know, I can tug on it quite hard. But if you use an ordinary little crocodile clip like this for a start, you know, it just can't connect with that, and if it does, it just falls off. It's too small. But even if it is smaller, like this is a, you know, it just doesn't, it just wants to fall off. And when you connect it up to a thin wire, see, there's nothing there. It just slides off. So that's why we're using these Kelvin clips, and they also, you know, they're gold plated things, so they have low resistance, so that's good. However, because they have two different connections to these tips, we have to connect them together, because we're just going to have one lead coming out of them, not two. So that now, in order to connect wires to this thing, they have to be soldered, and inside there is a spring. See if I can focus that a little bit better. Inside there is a spring. The first thing to do is to pull that out, and you can do that just with a small needle nose pliers. And what you do is you lift up this little that thing from the spring, put a little screwdriver under there, or a needle, lift it up, and then you can pull it out. Or sometimes you can just lever it out with the pliers like that, and it'll just slide out. And then once you've done that, you can actually slide these. You can grab onto the metal here that you got to solder to, and that'll slide out as well. But so another one here I have already done, and this is the spring, and there, and I put a mark. This, as you can see, there's a short leg and a long leg on the spring, and I don't know if there's any significance to that, but I put a little dot here on the body here. That's where the short part of the thing spring was. And as I said, these, they will just unplug, and I will do one at a time. And what we're going to be doing first is, I've got some other, a bit thinner, but it's going to be very short, silicone wire here. And what we want to do is to let's get this out of the hole. What we want to do is to connect from there, and it'll go past the little spring there, and then it is going to be soldered to the other leg there. So we need a length of wire about that long, so we can actually go and snip that off. Dunk. We're going to find a way to solder this wire on here, and this one has to go in that direction. So the first thing I'm going to do is to twirl these together. Okay, well, I'm set up. I have my little soldering station that I built in the other videos ready. Let's turn the temperature up a little bit. There, I'll try 330, see how that goes. And now I actually made up a little jig over here that I saw something similar advertised on, I don't know, it's Amazon or AliExpress. I wanted like $8 for it, so I printed this out on my 3D printer, probably for 8 cents. And I think it's working good. You just kind of jam the wires in there, and then you can solder them together. So we're gonna tack these two wires together. I twirl them together a bit because they're fine, very fine wire. That actually made it easier. A little bit of flux there, that'll help. Okay, don't forget to close the bottle of flux, because invariably I tip it over and then I got a sticky mess on my desk. It happened once. Alright, so soldering iron. That'll do it. There's already some solder on this this is a big chunk of metal, but yeah, it's working okay. Oh, this is this horrible lead free. You do that. This is MG Chemicals liquid rosin flux, I should say, and I use that for soldering wires. It is not good for using on SMD components on PC boards because it leaves a sticky mess behind. You need MTEC flux for that, but this is ideal for this kind of work. Alright, so there we go. Now comes the big test to see if it'll plug back into the body. Let's do it properly. Okay, so let's do this top one first. Slide it in there. There it comes. Okay, so that's the one. And now we're going to have to try the other one. Better. Right now it looks like they're not mating very well, but that will be taken care of by the spring when I put that in. Actually, I think I'll keep it down to 7 centimeters next time. Okay, so the wire is in. For some reason this one is twisted. Man, these things are fiddly. I think that's it. Yep. So that spring thing, the longer one, that's probably why it's longer, it holds the wire in place. So it can't come out. I was wondering about that. But nevertheless, I think a piece of heat shrink tubing around there would be a good idea. That. Right, plug in my little heat gun. All right. I will probably fill that up with some silicone or something to later on, but that one is done. We'll leave it as it is. All right. Now, this is the red one, and I often forget to do this, and then you got to desolder it and putting the little sleeve on first. And now we're going to solder it onto this thing here. In this case, I can just do the hole a little bit. With this kind of bright metal stuff, usually it's hard to solder unless you put a bit of flux on it. Waiting for the soldering iron to heat up again because it times out. Okay, that looks good. Just pushes in. Okay, so we've got one lead done. Now I'm curious how much resistance this lead has. A little bit longer than my average probes. Connect this to that one. And the plug goes to the other one. Okay. 18.4 milliohms. It's about half of what the normal probes have, so I think we can call that one a success. Now, I'm going to do the other one a little bit offline because I don't have a very good internet connection for uploading. It took me 24 hours to upload a video previously, so I've got to try to shorten these things. So I'll do some of the work offline and get back to you once I've done that. Okay. So I have soldered this together, and that's kind of how it looks like before I plug it into the body. And of course this is how it is supposed to go. This one's actually a little bit different. This black one, it had insulation on here, which of course I don't need, so I pulled it off. But I guess if you have a different separate connection from here and there, like the probes have on like the milliometer and so on, this is the insulation that was on there, some sort of foil, but as I said, I don't need that. Okay, so let's have a look if we can put this one together a little bit more, now that we're getting better at it, a little bit more elegantly. Okay, so I'll plug that in there. Now we're gonna plug this one in. Okay, too fiddly. It's gonna be hard to focus the camera in on that, I guess. All right. I get it that the spring holds those things in there. Okay. I made the wire only 7 centimeters long this time. That's a little better, easier to deal with than the other one. Okay, so now the spring, the tricky little spring. I'm wearing glasses. I think I would have to wear goggles if I didn't have glasses on, because this spring could jump right into your face, and that would be painful and could injure your eyes and stuff. So we want this being the other side of that wire, and I think I should focus a little bit like that. So the next thing to do is to get the short end of the spring here in front of the there's a little lip in there that stops it from jumping out before I push it all the way in. And it's hard to do this on camera, but I use this tiny little screwdriver to lift it up and over. There we go. I think, let me see. Yes, there she goes. So now we have that short end of the spring in front of that little lip that's in there, little tiny plastic lip. So now, with some care, we should be able to pull the spring in further and lift this over the top there a little bit, and there we go. See, much more, now we're getting a bit more experience with it, much more elegantly than before. And let me see, I think that's it. Yep, that's it now. Very good. Let's do the same thing as the other one with a piece of heat shrink tubing. Good. Now, heat gun again. will do it. As I said, I'm gonna squeeze some stuff in there to hold that. No, I will just pause this again because you've already seen me solder the little wire up. Okay, so I've soldered up the little plug, and now we're going to test this black one. "19 and a half." I think that's good. Now, let's do a few more little tests here. I just want to get set up. Okay, so let's have a look what happens when we use our new leads. I put the original probes on there, and when I touch them together, we can get it to settle down. It's about it varies, 19, 20, because I guess the plating on those probes got some resistance as well. Now let's plug in our new leads that we made up with the Kelvin Clips on there, and our solid banana plugs. And these leads are actually quite a bit longer than the ones that came on there as well. So there we go. 0.8 or 0.9 of an ohm. More than 50% better than the original leads. Okay, so that's all I've got for this run. There's some more videos coming on some little logic analyzers I've got, and some other stuff, soldering, desoldering, soldering irons, desoldering stations, and what have you. So keep an eye out for those, and I'll see you until next time.